Okay, now. We just completed a section on intercepts and everybody at least did well. Okay, at least everybody that did it, I think everybody did. So we're going to graph these equations and we're going to use the intercepts, which is the quickest and easiest way to graph an equation of a line. Okay, so y equals 4x plus 2. Now, when you write these out, I would really strongly recommend to you, I'm not going to ding you for points if you don't, but you're going to learn it much better if you write out what you're doing. Okay? So we're going to find the intercepts. Write this out. And if you get tired of writing, you probably could abbreviate intercepts as long as you're going to know in the future what it means. Okay? And you want to go back and look at your notes or take a test and stuff like that. Okay, so we find the intercepts. X-intercept. Y equals 0. That's what the x-intercept means. It occurs on the x-axis. It's a point on the x-axis where the graph crosses the x-axis. Okay? And out of the class, most people didn't use the intercepts correctly, although most people found the intercepts. Okay? But it's like found the intercepts, but didn't know what you found and didn't know how it applies to the graph. Made a very simple error. I'll point out that I think everybody knows it, but some people graphed it by a different method. We want to use the intercepts because, of course, that's what we just did. And as I say, it's the easiest way to do it. So the x-intercept occurs when y equals 0. So we solve 0 equals 4x plus 2. It's 12. Okay. It would have made the intercept too close to the origin. Okay. And so we get, and you want to do the steps. Make sure x equals -3. You're going to send me a picture of this, okay? When you do it. And I'm going to want to see the steps because if you get something besides x equals -3, I want to be able to tell you where you went wrong. Okay? Now I think everybody did the steps right. Everybody that found the intercepts got it right. It's a pretty easy equation. And if you do a much harder equation, you all done really well with their equations. So that's not going to be a problem. But make sure you show me the steps, just in case you have a little brain glitch, like you see me do all the time. Okay. So we have this. Now, they've abbreviated, especially after you've written out the intercepts. When you've done your intermediate step. 4 times 0 is 0, you get y equals 12. Okay. Okay, now what does this mean? Zero, x equals -3. X-intercept is -3, 0. Okay. Now x equals 0 and y equals 12. Y-intercept is 0 and 12. Right? Now, fully half the class at 1 point, -3, 12, which isn't even on the line. Okay. So. Careful. You on the line. Now, where to do it, over here, not on the board is like, there we go, okay? So what is on the line? It's simple. -3, 0. Here's the point 0, 12. You can draw a straight line through. Kind of messed up, you know what I mean. Fair enough. That's really easy. You did the hard part. If you found the intercepts, which ones. Okay, now if you did it by plugging in points, you went a lot of extra trouble. It's very quick and easy to do this. Okay. Also, plotting points, plotting 3 or 4 points to get a straight line isn't a method of this course. I would not give you full credit for that. Okay, I'd give you a couple of points, but I wouldn't give you full credit because this is what we're doing right now. This is what you need. What the open map told you to do. Okay. So, you know, the majority of the class either did this or used the wrong method. Okay. Now, if you want to make a table and plot some points, you'll see that they all lie in this line. Okay. And that's a good confirmation. There's nothing wrong with doing that, but that's not the method you want to use. Reason for that is we're going to get into functions here in a couple of weeks where or graphs where that method would be useless. You wouldn't know what points, you wouldn't know what X values to use. Okay. If we don't get into too much of that, we won't get into a whole lot of it in this discussion. If you still think that you got to plot points, just any old points, graph a function, and pre-calculus, it's really going to bite you. Okay. So I want to get used to using a method that'll always work. Now, if you make a table and you get just 2 points, if you didn't make a mistake on those coordinates, you will get a graph of the line. Okay. And then you maybe estimate the intercepts. Start with the intercepts. All right. And as I say, that's actually quicker than plotting all the points. Okay. Okay, so let's just do this from the reinforced. Now, let me make the other comment. I wrote all these words. Didn't just write a bunch of calculations. I wrote some words. Okay. You should be writing the same words, or at least conveying the same information. Okay. Because that reinforces to you 3 weeks from now, you're going to need to plot the equation of a straight line. And you go back to saying, okay, this is a point. I've got it. That's okay. Because you don't remember the logic of what the intercepts are. And the intercepts are very, very important throughout the calculus. The intercepts occur. X-intercept occurs when y equals 0. If you haven't written this out, you're skipping a step. Okay. That you really need to put in there so that it'll bore into your brain a little differently. Okay. A little better. You really need to write that out. Okay. If you want to really abbreviate it, first thing you should not leave out is the x-intercept occurs when y equals 0, y-intercept occurs when x equals 0. Okay. Those are the key things. I recommend you write out more words than that. You want to get used to writing logical sequences of steps. But I know you're pressed for time. Don't be so pressed for time you don't at least write this up. Try to find time where you can write the whole thing up. Okay? At least for a few problems. And always write this to remind yourself what the x-intercept is, what the y-intercept is. So when you put it on the graph, you know what it came from, you know what you did, you know how to find it. Okay? Okay, good. This goes with my emphasis on writing things out. Go a long way toward curing a real problem we have in math education, in which students come into the course. Wire is a prerequisite course, but they don't remember anything about their prerequisite course because they haven't bothered to actually learn. Okay? And maybe it's not just haven't bothered. Some courses are really tough. But you all are plenty smart to do this. Okay? So please do what I ask for your own sake. Okay, the other one, but this goes on quickly. Please. Okay. Now, it's kind of a good idea to write this, is this reminds you of what you're doing. Your method is to find the intercepts. Then all you gotta do is put them on the graph. So find the intercepts. X-intercept, y equals 0. So you solve 0 equals -1/2 x plus 4. Writing word solve is more or less optional. Okay, but so solve. Okay, this equation follows from this in a way that you really want to lock in. Okay, so you get this. And then we solve this and we get x equals. Okay. And I'm going to draw the little arrows. It reminds you to put these together and not like to put these two separate things together, right? We never put these together. They don't have anything to do with this graph. Anything to do with this function. Okay. And then the y-intercept. X equals 0. So solve y equals -1/2 0 plus 4. You get y equals 4. You put those together. Y-intercept is 0, 4. You make the graph. Here's a point 8, 0. Here's a point 0, 4, and there's your graph. Okay. And you don't have to mark 100 little points here and label them all, and 100 little points here and label them all. These numbers are bigger, you get numbers in the hundreds, right? You could easily get numbers in the hundreds. You're not going to do that. Just put a point here. It's about twice as far away from the origin as this. Okay. Now, sometimes you might get an x-intercept of 12,000 and a y-intercept of 4. Then you're not going to be able to draw both x and y axes to scale. If 4 is here, where's 12,000? Well, it's 3,000 times this far, okay? Which is about 6,000 inches, which is about 500 feet. You check me on that, that's off the top of my head. I don't know, something like that. Okay. So you have to go 500 feet out there. You have to draw an awful long way. Here there, you can draw a short line, put 12,000 here, but then 0,4 is gonna look like it's on the origin. Because it's so small, right? That makes sense? Okay. If you do that much, you know a lot about straight lines. Let's just take, I don't know, who wants to use this line, who wants to use this line? Thumbs up for this line, thumbs down for this line. Okay, probably gonna give me thumbs up, whatever I say. Okay, because thumbs down, like you're rejecting something. But that's fine, it doesn't matter. Okay, so I'm gonna look at this graph again. Now, I'm gonna make what I call a fundamental triangle. It's not a term that's universally used. In 100 years from now, and everybody understands that everything I've ever done is what everybody ought to be doing, they'll use it. Okay? And I'll probably be around to see it. Well, no. I don't know about you all. Doing all kinds of stuff with life extension. Probably be a while before it comes around. Okay, so we have this. Now, we have the line, course the line. Let's screw it. Now I'm going to draw a triangle. This point to this point. Here's the hypotenuse, that's the long side of the right triangle. Here are the two legs. They're parallel to the coordinate axis. Matter of fact, in this case, they're on the coordinate axis, right? Now, I could have drawn the triangle up here, and it would be equally good. Okay, so I can draw the triangle before, underneath, or above the graph, as long as the legs are parallel to the x and y axis. Okay. Then I'm going to indicate a direction. Well, we're going to go from left to right. So that I'm going to put an arrow here. Going from left to right. Now, that's one path from this point to this point. What's the other path that we can take along the sides of this triangle to get from this point to this point? Well, we could go from here to here, here to here to here, here, and get from this point to this point eventually. Okay? But the most direct path is just this. Right. Makes sense? Okay, now from here to here, how far is it from here to here? Show me with your fingers. Yeah, there you go. Okay, obviously 4, because it's in the negative direction, right? Pretty obvious that that's a negative y direction, since the y-axis has an arrow going up this way, right? The opposite direction of the arrow means that this is -4. Well, I call this rise. Might not be able to read that word that says rise. I'll draw a triangle later. Okay, so the rise is -4. Make sense? Why is this a rise? Well, we're going up or down, right? And negative rise meaning we're going down. If it was +4, that means we'd be going up, right? So this point is lower than this point, so our rise is -4. Our run is what? Show me the fingers. Yeah, put a negative sign in front of it. Right. No, I didn't say that. Okay. The always have a negative sign. I've always said that. Run is a, put a positive sign on it. Okay. Well. Does anybody know the definition of slope? It's the rise divided by the run. Now you can calculate this y2 minus y1 over x2 minus x1. It's a perfectly good formula, but we're not interested in just calculating it. We want to understand it. In this picture is a basis for understanding it. Okay. So we start with this definition, and we'll come up with a formula. Okay. So what's the rise divided by the run? -4/8, which is -1/2, right? So there's the same calculation up here, where it would be a good place to write it. Instead of down here, away from the prime. Okay. So when you write this out, better leave yourself room to do this like I did. Okay. And then I like to see is I like to see a 1/2 here, -1/2. Oh shoot. Okay, there's a negative sign there. You might not be able to see it. And put a box around it because a number next to a line means the length of the line. Okay. A number with a box around it in the convention that I like to use means slope. Okay. You don't have to use that convention for the rest of it. I think it can be used. Especially when you're trying to do interpretation. Okay. You know, what does this mean given situation? Incidentally, I've got a good thing I didn't actually go through the steps of solving that equation. I wouldn't have gotten the right answer. Okay. Now, equation was y equals -1/2 x plus 4. Do you see the slope anywhere in that equation? Yes. Right here is the slope. And what's 4? See 4 anywhere in that graph? The y here. Okay. For any straight line, any straight line can be written in the form y equals mx plus b. We're gonna stick that dot. Okay. This is just one example. The slope appears here, the y-intercept appears here. It always works. Okay. Okay, well. Let's come back to the first equation we had. Okay, there it is. Sketch and lay